Okay, so the last thing that we're going to do when we talk about the unit circle is we're going to talk about the radian measure. Okay, radian measure is kind of like instead of using degrees to get to a certain angle, you're talking about the arc length. Okay, and so you're like, well, what do you mean arc length? Okay, well, and I feel like it's a reasonable question, to talk about, how else would you talk about degrees? Well, the Babylonians said, hey, if a circle is cut up into 360 little pieces, everyone being a degree, they picked 360 degrees because so many things are divisible into 360. Okay, I'm not sure if that's why they picked it, but it certainly is a good factor because 5 goes into it, 3 goes into it, 12 goes into it, 60 goes, so many things divide into 360, more than just if they went out of 100. Okay, 3 is a very clinky thing to try to put into 100. You're like, it doesn't go nicely. No. So I think the thing that I would talk about would be, if you're talking about starting at 0, okay, if you're talking about 0 or 0 degrees, and then 360 degrees would be all the way around a circle. Well, what is the circumference if you go around a circle who has a radius of 1? Okay, let's think about circumference is equal to 2 pi r. Okay, so 2 times pi times 1 would be 2 pi. Okay, so if you go around a circle with radius 1, the length that you would travel around one circle is 2 pi. Okay, and so the way that we would talk about that is the number of radians that you would travel is 2 pi. Like, yeah, it doesn't help me to know what a radian is. Well, a radian is a radius, okay? It's how many radiuses of that circle you have gone if you go around a circle. So let's think about this. And this is not normally how you actually talk when you're speaking, but it is a valid way. That's how you measure radians, is how many radiuses you traveled. So if a radius of the circle is 1 unit long, okay, and if you took that exact length, you're like, okay, let's use like a tape measure and be like, let's measure, okay, if you went from here to here, you would have gone about, okay, 1 radius. Okay, so if you go another one of those measurements, you would go 2 radians or 2 radiuses. Go another one of those, and you had gone 3 radians. So halfway around a circle is a little bit more than 3 radiuses around it. So let's keep going. So 4 radiuses, 5 radiuses. That's a little short. So 5 radiuses, 6 radiuses, and then a little bit more. Okay, I didn't measure it the best, but I'm just kind of eyeballing it. Okay, so how many radiuses does it take to get around a circle? Well, 2 times pi is 3.14-ish. Okay, so that's 6.28 of every radiuses. So if your radius is 1, it's 6.28 units. So it's about 6 radiuses to get around every circle, which makes sense because 2 times pi is a little bit more than 6. You're like, you're not making sense. Well, I'm going to tell you, they're like, go 2 radiuses around the circle. Well, then you'd end up about here. Okay. And there is a conversion factor, and you'll do that when you get a little older. Like, how many degrees is 2 radiuses? Okay, because every circle is a similar figure. So if you go 2 radiuses on a small circle, it's the same degrees as if you would go 2 radiuses on a bigger circle. Again, it's kind of weird way to measure how far an angle of a circle, but it's kind of like talking about the arc length. Okay. The length of the arc you've traveled to get to that angle on that circle. So it's a different way of measuring. The reason why we use radians or radiuses, okay, no one says radiuses, but radians measures because a lot of formulas when you get older don't work in degrees. They only work if you use radian measure, okay? And it's a proportional distance you've traveled around the circle. So it's more related, more directly than degrees, okay? And so let's kind of think about, let's backtrack a little bit and say, okay, so you've got all the way around the circle is going to be 1 circumference, which is 2 pi. So that means, let's think about the fraction of the circle you have gone if that's going to be all the way around the circle. Okay, so we're just going to basically work with fractions to talk about what we have. Okay, so that, I guess that's what we can agree on, to be like, okay, if all the way around the circle is 2 pi radiuses, or 6.28 radiuses, or 2 pi is the circumference of every circle, well, then that means if you go halfway around a circle, you're going to go just pi. okay? And if you go a fourth of the way around the circle, you're going to have gone halfway to pi over 2. So halfway around the circle is pi. All the way around the circle is 2 pi. So if this is half pi to go 90 degrees, this would be pi or 2 pi over 2. So 1 pi over 2 plus another 90 degrees is 2 pi over 2. Then you're going to go another 90 degrees, that's 3 pi over 2. If you go another 90 degrees, that is 4 pi over 2, which is 2 pi. So we're just kind of saying, can we count the distance we've gone in terms of the circumference? Okay, if all the way around the circle is 2 pi radians or radiuses, how much is incrementally, when you go part way around a circle? What is it? So pi is going to be halfway around a circle. 2 pi is all the way. Half the way to pi is 90. 3 pi over 2 or 1.5 pi is going to be 270 degrees. And then 2 pi is all the way around. So the next thing we could talk about would be, well, if halfway to pi is 90 degrees, what would be 45 degrees? Well, 45 degrees is going to be pi over 4. Okay, a fourth of the way all the way to pi. So a fourth of the way to pi, 2/4 of the way to pi. It reduces to pi over 2, so you should write pi over 2. This is 3/4 of the way to pi. And this would be 4/4 pi. It does reduce to pi, so you should put pi. And then if you go 45 more degrees, this is going to be 5 pi over 4. If you go another 45 degrees, you're going to get 6 pi over 4. Okay, just do it 3 pi over 2. And then if you go another 45 degrees, you're going to go 7 pi over 4. Okay, and if you go another 45 degrees, you're going 8 pi over 4, which reduces to 2 pi, so put 2 pi. So we're increasing it by a fourth of the way to pi. Every 45 degrees that you travel, you add on 1 pi over 4. So we're breaking up how far did you go, to get to that part of the circle. What fraction of the 2 pi are you going, okay? If you do by 30 degrees, okay, 30 degrees out of 180 is 1/6, okay? So a sixth of the way to 180 degrees would be if you go to 30 degrees. So that would be pi over 6. And so if you go 30 degrees, you get pi over 6. You go another 30 degrees to get to 60, you're going to have 2 pi over 6, which is pi over 3. If you go another 30 degrees to get to 90, you're going to get 3 pi over 6, which is going to be pi over 2. If you go another 30 degrees, you're going to get 4 pi over 6, which is 2 pi over 3. If you go another 30 degrees, you're going to get 5 pi over 6. So you should put 5 pi, it doesn't reduce. If you go another 30 degrees, you're going to get 6 pi over 6. Hey, that's just pi. Leave it as pi. If you go another 30 degrees, you're going to get 7 pi over 6. It doesn't reduce, so leave it as 7 pi over 6. You go another 30 degrees, you're going to get 8 pi. Oh, 8 pi over 6 reduces, doesn't it? It's going to be 4 pi over 3. If you go another 30 degrees, you get 9 pi over 6. That reduces to 3 pi over 2, so leave it as that. Go another 30 degrees right here, and you get 10 pi over 6. That's 5 pi over, that is not true. 10 pi over 6 would be 5 pi over 3. Another one, okay, is going to be 11 pi over 6. And if you go another 36, you're going to get 12 pi over 6, which is going to be, or 6, which is going to be 2 pi. So leave this as 2 pi. So we've got basically some fractions. And once you get to pi, notice the values get improper, okay? And so bit by bit, you're going to see this again next year. I just want you guys to have a filled out unit circle so that you can have these measurements. So I'm going to say, okay, use your unit circle and answer the questions. Find the sine, find the cosine, find these different values of those angles. And I want to remind you what we have. We've got, if you're talking about a triangle, if this is theta, okay, you go to an angle. If you answer x or x over 1, you're going to get cosine. If you do y or y over 1, you're going to get sine. So the ordered pair you see, you're going to see cosine theta. That's your x coordinate or x coordinate over 1. The y coordinate is going to be sine of theta, okay? And if you want to do tangent, you do y over x. Okay, and remember to reduce and rationalize your answer. Okay, all right. Thank you so much. Have a good day.